lecture series of basic electrical engineering. In this, we are seeing the module 5, that is measurement and instrumentation. In the same, we are going to see the topic that is standards, errors, and calibration, which is very much essential for particular instrument. So, what is standard? Some reference is known as a standard. Before going for instrumentation, we should have a particular standard. So for that, we have given a certain analogy. Here you can see an target. In this target, so this is the target point. Here this is the exact midpoint. If it is exactly near the midpoint, or this may be considered as a true value. So this is very accurate and precise. So this is meeting the standard. If it is in this target, but it is not in the midpoint, so it is not precise, but okay, it is accurate. So here one more thing is there. Here you can see the number of target points, so which is in one particular point which is crowded over there, but it is not in the target, so it is not accurate, and it is precise. It is precise because continuously we are getting the same values. And once again, one more analogy is there, not accurate and not precise, because it is dispersed, it is not crowded, it is dispersed, the values, and also it is not attaining the target also. So this is not accurate and this is not precise. So it is not correct one. So these things will be a type of errors also, and these errors arises when it is not meeting the standard. So we will come to the topic, that is what is meant by standard. So all instruments are calibrated at a time of manufacturing against the measurement standard. The standard of a measurement system is nothing but a physical representation of a unit of measurement. A standard means it is known for its accuracy measure of the physical quantity. The different size of standard of measurement are classified as: first one is the international standards, second one is primary standards, third one is the secondary standards, and fourth one will be the working standards. We can see each type of standards in detail. So first one is the international standard. So this international standard are defined as per the international agreement, and these standards are mentioned above or maintained at the International Bureau of Weights and the Measures, and are periodically evaluated and checked by means of the absolute instruments in the terms of fundamental units of the physics. So it may be having a particular headquarters, in that it is always kept intact. The international standards are not available to ordinary users for calibration purpose. For the improvements in the accuracy of the absolute instrument, the international units are replaced by absolute units in 48. The absolute units are more accurate than the international unit. So there will be a bureau, in that we will be having weights or measures or whatever the physical quantity has to be measured in terms of the absolute measurement, and its accuracy is also more. And it is after 1948. Previously it was taken care by international units, but later it was carried by the absolute measurement units. So this is about the international standard. Next one is the primary standard. These are highly accurate absolute standard which can be used as ultimate reference standard. These primary standards are maintained at national level. So previously we saw about the international level, but this is about the national level standard laboratories in different countries. So it may vary from continent to continent and country to country. These standards representing the fundamental units as well as some electrical mechanical derived units are calibrated independently by means of the absolute measurement of the national laboratories. These are also not available for use outside the national laboratories because with reference to temperature, with reference to other physical parameters, there is a chance of changing the value of the primary standards. So these primary standards is meant for calibration, and it can be verified with the secondary standards. Now we are going for the secondary standards. As mentioned above, the primary standards are not available for use outside the national laboratories. The various industries need some reference standards. So, to protect highly accurate primary standard, the secondary standards are maintained, which are designed and constructed from absolute standards. These are used by the measurement and calibration laboratories in industries and are maintained by the particular industry to which they belong. Each industry has its own standard. So this is the secondary which can be used only in industries. Final one is the working standard. These are all the basic tools of measurement laboratory are used to check and calibrate the instrument used in the laboratory for accuracy and performance. So this is the final thing where we can intervene and we can measure that. So some examples for international standard, you can name it as International Organization of Standardization, that is ISO. Then International Electrotechnical Commission, that is IEC standard, that is the second one. And third one, American National Standard Institute, that is ANSI, that's the third one. Then fourth one may be Standards Council of Canada, SCC, that is also international standard body. And finally, we can name it as British Standard BS. So this is also type of international standard. So this may be followed strictly by all type of calibrating the instrument. Next, the very much important is the error. So what is meant by error? So there is no precision and there is no trueness of the value. So there is some uncertainty in the measuring value. So that is known as the error. So here you can see the target is not reached, so it is an error. So this is the correct, accurate, and here the precision is also reached. So this point is linear. So this is known as the errorless measurement. Here this is the bias. So there is no relation at all here. It is very inaccurate and uncertainty also is there. So this is the exact thing which the instrument should give continuously or repeatedly for a measuring value. So what are the errors in measurement? The types of errors are as follows. That is nothing but groove errors, systematic errors, and random errors. So these groove errors is done by human being. A systematic and random here you can see. So this is actually a systematic error. Here you can see the target is not yet reached. Random error, it is almost there. Okay. So what are the comparison of this? It has poor accuracy, definite causes, and it can be reproducible. But random error, it is poor precision. It is caused due to poor precision, and it is non-specific cause. It is not reproducible. So these are all about the basics of the groove error, systematic error, and random error. Now we can see each in detail. Groove error. The groove error or occurred due to the carelessness or lack of experience of the employee or the human being. These error also occur due to incorrect adjustment of the instrument. So a well experienced person should use a particular instrument. If not, we'll get these groove errors. And these errors cannot be treated as mathematically wrong, but it can be treated as personal errors. So how to minimize these groove errors? The complete elimination of this error is not possible because it should be the person's care should be taken. Taking great care while taking a reading, recording, and calculating the result, which depend upon only on the reading. At least 3 times you should take the reading by different persons, so you can reduce these errors because it is individual's concern. Next one is the systematic error. Systematic error, the constant uniform deviation of operation of instrument is called systematic error. So continuously you are getting the deviation. It is not accurate. Though that systematic error are mainly due to the shortcomings of the instrument, maybe some shortcomings or pitfalls in the instrument, the characteristics of the material used in the instrument, maybe worn out parts, aging, and environmental effects. So these are all the main thing will be coming under the systematic error. So we can see one by one. First one is the instrumental error, second one is the environmental error, third one is the observational error. So the shortcomings of the instruments. So there are three reasons. First one, that is these are because of the mechanical structure of the instrument. For example, friction in the bearing, irregular spring tension, reduction in improper handling, hysteresis, gear stitching, spring. So these mechanical wear and tear coming under this. So this may cause error in the instrument. So this can be avoided by proper instrument planning, and procedure should be there, and applying the proper correction factors in calibrating the instrument carefully against the standards. By doing the calibration, we can identify the error easily and we have to rectify it. And misuse of the instrument. So this is a very very serious error. So we should know the procedure how to conduct the experiment and how to connect it and how to take the result. In case of poor initial adjustment, improper zero setting, using the leads for higher resistance. So this may be, for example, polarity changing. So these and all will be causing the misuse of the instrument. So definitely it will cause a serious error. So we should know how to use a instrument. Then only we'll get a correct value. In loading effects. So using this is nothing but the correction factors by the manufacturer. So if you're not using the correction factors, you will get the loading effect error, and using the arrangement which keeps the surround condition constant. So certain things has to be maintained with the surroundings constant, for example temperature or ambience, whatever it may be, and reducing the effect of dust humidity on the components by sealing the components so that we can reduce this loading effects. And external field may be a magnetic or electrostatic shields or screens. So some equipments are sensitive with those electrostatic and magnetic fields, so it should be shielded properly. So by using such a way of such procedure to avoid the loading effects, and it should be calibrated so we can get the error free in the loading effects. So that is the thing here. It can be avoided by using the instrument intelligently and correctly. The next one is the environmental errors. These errors are due to external condition of the measuring instruments. So these will be resulting in the environmental error. For example, temperature change, pressure change, thermal EMF will be there, aging of the equipment, frequency sensitivity of the instrument. So these are the environmental condition which affects badly on the instrument, which causes the environmental errors. And next one is the observational error. So this is by the user. So while he is observing, there is a chance of getting the parallax error, and while reading the meter wrong scale selection. So if there is a multiple scales, there is a chance of reading the which is not relevant to it. So how to minimize this error? So it can be minimized by using the mirror uh, behind the scale and a knife edged pointer, sharp pointers that can avoid it. And the systematic errors can be subdivided into static and dynamic errors. So this limits the measuring device's dynamic errors. And the next one is the random errors. So some random error result through the systematic or instrumental errors or reduced or accounted to it. So this is quite irregular or not in particular. So such errors are caused by unknown factors. So we should be careful in this for reducing this errors. On this, the way to reduce the error is by increasing the number of observations. By if you're getting 5 readings, you have to get 10 readings, and by using statistical method to obtain the best approximation of the reading. Next one is the important thing, that is the calibration. It is nothing but you are going to compare the standard. The calibration is the process of making an adjustments or making a scale so that the readings of the instrument agree with the accepted and certified standard. In other words, the procedure of determining the current value of measurand by comparison with the measured or standard ones. Calibration offers the guarantee of the device, the instrument it is operating with required accuracy under stipulated environmental conditions. The calibration procedure involves the steps like visual inspection for various defects, installation according to the specifications, zero adjustments, etc. The calibration is the procedure for determining the correct values of the measurand by comparison with standard ones. Standard of the device with which comparison is made is called standard instrument. The instrument which is unknown is to be calibrated is known as the test instrument. So that the calibration will be carried for the test instrument and it is compared with the standard instrument. So this is the best example for the calibration how we are doing with a meter. How it is calibrated with other parameters. So there are two types of calibration or two methodologies we can use against the test and the standard instrument. First one is the direct comparison. Second one is the indirect comparison. Direct comparison, a source or a generator applied to the input to the meter under test. The ratio of the indicating and the known generator value gives the meter error. In such case, the meter is the test instrument, the generator standard instrument. Deviation of the standard value is compared with the allowable performance limit. So with the help of direct comparison, a generator or source also can be calibrated. So this is the direct method of the calibration. Second one is the indirect. The type of test instruments is compared with the response of the standard instrument of the same type. That is, if the test instrument is a meter, standard instrument should be also a meter. If the test instrument is a generator, it should be also a generator. If test instrument is a meter, the same amount of voltage or current has to be applied and it has to be within the nominal level so that it can measure both the standard. So this is about the calibration. So in this lecture you might have learned about the calibration as well as from the first, that is what is meant by standard, second one is what is error, third one is calibration. Thank you for watching.